Hi, my name is Thenuk, and me and my partner Nathaniel would like to present to you Labyrinth, a fun and strategic puzzle game. Many of you might know the mythological creature known as the Minotaur, who would chase and kill those who entered his labyrinth. Well, that's basically the premise of our game, a puzzle maze game where you try and escape an enemy, stronger and faster than you are. But before I let Nathaniel take over, if you guys are thinking about joining the competition, I would highly recommend it. It is so much easier to learn Python by applying it to a game and much easier than reading textbooks and watching lectures.
Hey, I'm Nathaniel, and after a couple weeks of brainstorming ideas and setting for a maze-style program, we began the foundations of our game, starting with plotting and basic functions. We first coded this basic function using the code that we learned from earlier labs to make a grid, where the floors and the walls are determined by an array of oriented ones and zeros, to make this right here, which is not too bad in my opinion. The movement function returned coordinates which correlated to a certain directional change for the player, while the main function served as the overarching, all-encompassing function, which runs the rest of the code. Next up was pathfinding, and we used breadth first search to return the path between the enemy and the player. All the lists are first initialized, where the queue collects tiles to be checked. Visited tracks already seen tiles, and parent traces the steps to each tile. From here, the next tile in line is selected from the queue list, and its neighbors are all checked. And if the neighbor is not a wall and hasn't already been checked, it is added to the queue to be checked later. This process continues until a goal has been found, where it retraces all the way back from the goal using the parent list and adds each step into the path list until they've all been added in reverse order, where our final step is to reverse the entire list and get the path from the enemy to the player. Now, from here, with this basic pathfinding, we ran into a bug where the enemy was far too overpowered due to there being no restrictions on his movement, causing him to take the exact path and get our player every single time. Our next step from here was to fix the enemy movement, which took us about a week to do. We countered this by locking the movement direction of the enemy to whichever direction was signified by the first step of the obtained path. If the path required the enemy to change directions, it would stop early, and if it didn't, it could move a total of 3 steps before stopping. Now, it was around this point where we introduced the object-oriented programming in one of our ENCMP lectures, and after some discussion, we decided to incorporate classes and objects into our program. So, in our third version of the program, we changed this block of code, which is all one level mind you, to these 3 integral classes. First, the level class, which focuses on map generation and plotting each point. Then, the player class, which focuses on moving the player. Finally, the enemy class, which focuses on pathfinding and enemy movement from earlier. We ended up benefiting quite greatly from the switch to OOP, as it works with classes which store the logic of an object, its behavior, and any functions related to it in a single class, like the eggs belonging to one basket. This made the continuous regeneration of each component for each level so much simpler. And in the case where we wanted to add features to either the player, enemy, or the level in the future, we could just simply add it to the respective class and watch it be incorporated into our code seamlessly thanks to the convenience of object-oriented programming. Asking yourself questions like those on the screen right now can help you understand your code and whether or not you should be looking into implementing some classes into your code. If you find yourself saying no to most of these, then functions should be able to suit you just fine. But if you find yourself saying yes to at least a few, as did we, then I really recommend that you look into implementing some object-oriented programming into your code, as it can make the entire development process far more efficient. So, all that was left for the final version of the Labyrinth was to add the 5 levels we had designed, creating a title, level selection, and game completion screen, and just like that, we finally finished the Labyrinth.
Before we end it off, let me give you guys some advice when making your own game. The hardest part is getting started. Start early and brainstorm for ideas as soon as possible. Once you get the idea, it's important that you plan out your project, starting with a base model with your basic mechanics, and then polishing those mechanics for a final product. If you're working with a partner, make sure you're working on completely separate parts of the project. That way, you don't get in each other's way. And lastly, don't be afraid to ask for help and use all the resources available to you. After all, the goal of this competition is to learn Python in a way that can be useful to you.